Welcome back to this lecture. So this is the last topic of unit 2. So in this lecture we will talk about the parametric productive model, and in this there will be two models we will talk about, that is cosmic full function point, and we will talk about the second model, that is COCOMO second model. So these are the contents. As I told you, I will first of all I will discuss about the cosmic full function point, and then we'll move to the next model, that is COCOMO second model. So as I told you, these are the parametric models. So these are the four parametric models. So function point is having three models: average function point model, and second one is Simon's or mass second function point model. Third one is cosmic function point model, and fourth one is COCOMO 81, that is a version 1, and COCOMO second model. So first of all, I will talk a little bit about the average function point model. So as average basically worked in IBM, and he was basically needed a way of measuring the relative productivity of different programming language. So he was basically trying to find out way to measure the different the productivity of different programming languages. So he needs some ways of measuring the size of an application without counting the line of code. As we measure the size, you have already seen that we measure the size with the help of SLOC, the source line of code. So in this case, we count the line of code, and after that we measure size. But average basically was finding out some way through which without this counting of line, he will be able to measure the size. So he identified 5 types of components or functionality in an information system that I will tell you in next slide. So he counted, in this case, counted occurrence of each type of functionality in order to get the indication of the size of the information. So based on these 5 types of components, he was basically counting this line of code without measuring the size without counting the line of code. So as I told you, there are 5 function types. So these are the 5 function types that average basically find out. First one is LIF or logical interface file. Second one is external interface file. So first of all, I will talk about LIF. So what is basically LIF or logical interface file? So in this case, it basically equates roughly to a data store in a system analysis term. So what is this logical interface file? So whatever the data that are created and accessed by a target system, suppose there is system target system, and whatever the data is created and stored on that data store, that is basically a logical interface file. That file will be created, that will be a logical interface file. Second one is external interface file. So in this case, as there is a various application from which you are getting the data. So where data is retrieved from a data store, which is actually maintained by the different application. So suppose there is a common data store or database, and various applications are basically retrieving the data. That file will be known as external interface file type. Next one is, that is third one is external input type, and it is denoted as EI. So all the input transactions which update internal computer files are basically these files, external input file, and same as transactions which extract and display data from internal computer files, that will use to generate the to creating the reports and all, and that will be known as external output file. And the last function is external inquiry function, that is denoted by EQ. So in this case, basically the data which are retrieved only for inquiry purpose, that are known as this EQ type. So it's all about this part. Now coming to the next, that is function point mark or Simon Mark second model. So it is basically developed by Charles R. Simon. That's why it is also known as Simon function point second model, Mark second model. And this one was also used for developed for software sizing and estimation, and it was basically built on the work that was done by the average that we discussed in the previous slide. And he worked originally for it was originally for CCTA, that was an organization, that is an organization, and should be compatible with this SSADM. Mainly it is based on the UK, and he has developed basically developed parallel with this average function point model that we discussed previously. And this method is a simple method. Now coming to the cosmic function point, that is our major concern. So in case of cosmic function point, we basically count the function points on the basis of these data or entries, just like entries. So it is movement of data into software component from a higher layer or peer layer. So whatever the data we are basically entering into the software component with the help of higher layer, that will be the entries. Exit, it is just reverse of this, that is the movement of data out. So from the software component to the higher layer, it will move, the data will move, that will counted as exist. Second one is reads, so data move, that is basically a data movement from persistent storage. So whatever the storage is, either data store or database or any hard disk. So if data move from this storage, persistent storage, then it will be treated, counted as reads, and the reverse of this means data that is moved to the persistent storage, it will be known as writes. So these are the four counts function. On the basis of this, we calculate this function points, and each count will be counted as one cosmic function size unit. So its unit will be CFSU, that is cosmic function size unit. So on each functionality, one each count we will consider at 1, and we'll calculate like this. Now coming to the next one, that is COCOMO 81. So it is also known as COCOMO 1 first model, and after that we'll discuss COCOMO second. So this COCOMO 81 is basically based on the industry productive standard. So it was made according to the industry productive standard, so that various software development productivity or the organization was basically used this model, where the database was constantly updated. In this case, database basically constantly updated, and the formula for the basic model is effort equal to, suppose we want to calculate effort, so it is equal to C, that is constant, into size power k. K is also a constant, and C and K, as these are constant. So it basically depends. The value of this will depend on the type of system, as the type may be organic or semi-detached or embedded system. So it depends on this, and in this case, size is basically measured in KLOC, that is thousands of line of code. So we measure size in this unit. So as I told you, this COCOMO constant, that is C and K, the value of these are depends on system type. So just for example, if it is organic, means broadly information system, then the value of C will be 2.4 and K will be 1.04. If it is semi-detached, then value of C will be 3.0 and K will be taken as 1.12. And for a embedded system, it will be 3.6 and value of K will be 1.20. So as I told you, after COCOMO 1, COCOMO 2 came because of various limitations that was there in COCOMO 81. As this COCOMO 81 was basically developed with some assumptions. At that time, as it was developed near about 81, it is at that time very few model was there, and waterfall model was the popular model at that time. So, as we know that in case of waterfall model, basically used in all the software basically developed from the scratch. So this model was used for calculation and all. But as we know that from that to now, there have been various models developed. So this COCOMO model, using COCOMO model is COCOMO 81 model, basically very difficult. So COCOMO second model was developed because of the limitations of first model. So COCOMO second incorporate a range of submodels. So we can say that this model is basically divided into some other model, submodels. That is, four submodels are there. So what are these? First one is application composition model. Second one is early design model. Third one is reuse model, and fourth one is post architecture model. So in case of application composition model, it is basically used when the software is composed from existing parts. So if we are making any software from the existing part, or from the whatever the suppose some parts are already exist, and we are going to make the application, then we use this some model, that is application composition model. Early design model, this model is basically used where when we are having requirements. So in this case, requirements are available, but we have not started design. So we can use this sub model COCOMO second, that is early design model. A reuse model. So reuse model is basically used to compute the effort of integrating reusable components. Suppose we want to compute the uh, effort to integrate various reuse components. So we can go for this reuse model. And the last one is post architecture model. It is used once the system architecture has been designed and more information about the system is available. So if design is ready, available, and it is ready, and we are having more information about the system, then we can use this. We can go for this post architecture model. So these are the four sub models. So as it is updated version of COCOMO, so there are various or different COCOMO models for establishing estimating at the early design state to post design architecture, as we already seen. So the core model is having this formula for the calculation of person month. So person month can be calculated using this one, that is PM equal to A, it is basically a constant, into size power SF. SF is basically a scale factor that we will discuss in the next slide, into EM, that is effort multiplier. EM1, EM2, EM3, and so on. And this diagram is basically showing the different accuracy of the different COCOMO second estimation. So as you can see, the estimation is met at a point So accuracy of COCOMO II is more. Now coming to the scale factor, COCOMO II scale factor, as I told you. So for this, for the calculation of this, as it is basically based on these five factors. So what are these five factors? First one is precedentedness. In short, it is denoted as PREC. So this PREC is the degree to which there are past examples that can be consulted. So suppose it is basically the case where you are having some past example or past uh, projects. So you can calculate this one. Second one is development flexibility. Flex, that is basically a degree of flexibility that exists when implementing the project. Third one is architecture or risk resolution, that is RESL. It is the degree of uncertainty about the requirements. So if the requirements is uncertain or changing, so this one, the degree of uncertainty can be calculated using this one. And team cohesion, that is the cohesion between the team, among the teams. Process maturity, that is denoted by PMAT, that could be accessed by the CMMI, that is capability maturity model integration. So this table is basically showing the different values of these five factors, scale factors. So this one is showing these five factors, and these are the different values from very low to extra high. So these are the values showing. Suppose for PREC, very low value is 6.20 and high value is 0, and low value is 4.96. Nominal value is 3.72, high is 2.48, and so on. So it is given, a table is given. Now we can take an example. So in this example, where this PREC is very high, so in this case we can see that if PREC is very high, then this value will be taken. So we have taken this score 1.24. Same as flex is very low. So flex is very low, that means the value will be this one, 5.07. And then RESL is high. So RESL is high, so we will take this value 2.83. Same as team has high score. So team is having high score, that means this value will take 2.19. And PMAT is low, so PMAT is low, so we'll take this value 6.24. So by this way we will take the value from this table, and after taking this value we can calculate it. We can calculate this scale factor by using this formula. What is this? B plus 0.01 into scale factor values. So this scale factor values what we have been calculated, we will just do the summation of this, to take the summation of this. So when we will put it, so value of B is 0.91, then plus 0.01, then this value, that is 1.29 plus 5.07, then 2.83, 2.19 and 6.29. When we will calculate it, we will find out this one, 1.08. So here we can calculate its person month by putting these values. So A, value of A will be this 2.94. Then we are calculating for 10 KLOC. So the size will be 10, and this SF we have been calculated here. So we'll put here. So it will come to 2.8%. So by this way we can calculate person month, and these are the references. You can refer these references. Thank you. Thanks to all.